Alright, so in this we're going to talk about translations, reflections, and dilations of functions and how it's related to matrices. Now, a transformation is where you're mapping the different points onto another one. So we're mapping the set of points, which we call a pre-image, and then we put it into a new image. So, translations are a fairly straightforward one. All you really need to do to find the new set of points is to take the original set of points and then add it with whatever you're translating. So, cyclist in a bicycle race needs to move from the front position at 0, 0 across 2 positions to the left so that the other cyclist can pass. So what that means is we'll write down 0, 0 for our original points, and then our 2 new points is going to be -2 and 0. So then our new points are going to be -2 and 0. Or if you like, in x and y notation we have -2, 0. You can do this for any size matrix. For this one, for example, we have A, B, and C to figure out, which is going to be -1, 3, 0, 2, and then -2, 1. Then if we add some form of translation onto there, so A, B, C, D, E, F, doesn't matter what it is really, we get 2, 4, 3, 3, 1, and 2. So, to find this matrix, we simply rearrange this and subtract it, so we get A, B, C, D, E, F equals 2, the matrix on the right, subtracting the original matrix. So then we get a 3, 3, 3, 1, 1, 1. In other words, the translational matrix would then be 3, 1, because we're just doing this for all the points, but really it's just one of the matrices. So just remember, you have to change it back. Alright, determine the image equation when the line with equation y equals x plus 1 is transformed by the translation matrix t equals to 2, 1. Now, we want our new points are going to be equivalent to the x and y adding on to 1, which then tells us that x and y is going to be equivalent to x plus 2 and y plus 1. Now just be very careful, you might be tempted to just say, oh, we're just going to add 2 and plus 1 to each, but you have to keep in mind that that's the original, so when we put it back in, it has to be the new ones in the original ones in terms of the new ones. So we then, after we get to this point, we have x dash the new one equals to x plus 2. That means in terms of the old one, which we're going to sub it back in, you'll see why in a second, it's going to be equivalent to the new one minus 2. We'll do the same for the y one, so y dash equals to y plus 1, so then y is equal to y dash minus 1. We then put this into the original, because we want to know how this is related to the new one. So y is the same as y dash minus 1, and then x is the same as x dash minus 2 plus 1. So then we go through and work it out. X dash minus 2 plus 1 equals to y dash. So then y dash is equal to x dash. Okay, so determine the image equation when you have an x squared. So let's follow the same process. We have x dash and y dash equaling to xy plus our translation matrix. So then x dash is equal to x minus 3. Rearrange it because we sub in the original, sub in the new one into the original one. We'll do the same for the y. So then we get y equals to y dash minus 1. So let's sub this in. We have y equals to x squared. And then we get y dash minus 1 equals to x dash minus 3 squared. Then put the 1 over and we have the answer. Okay, so for reflections and dilations, you just simply have to multiply the matrix. Then if you need to, use the original and rewrite it out. Alright, find the image of a point negative 2, 3 after a reflection in the x-axis. So if you have a look, the x-axis one is this one. So x dash y dash is equal to 1, 0, 0, negative 1, negative 2, 3. And remember to multiply matrix, we do rows by column. So then we get negative 2 plus 0 on the top, and then on the bottom we get negative 3. And this should make sense because if you reflect the x-axis, any positive y's becomes negative, and then negative y's become positive. And then the y-axis, we do the same thing. So we get negative 1, 0, 0, 1, negative 2, 3. So then you should have 2, 3. Okay, find the image equation after y equals to x plus 1 all squared is reflected in the y-axis. So just keep in mind that we want x dash y dash equals to negative 1, 0, 0, 1 times x of y. Now we need to do the same thing as before where we rearrange it. So we have negative x equals to x dash. So then x is equivalent to x dash, negative x dash, sorry. Y is equivalent to y dash, so we can just leave that. So then putting this into the equation, we have y dash equals to negative x plus 1 squared. However, if you factorize out the negative there, you then have x minus 1 squared. And just keep in mind when you square a negative, it doesn't change it, so then we get x minus 1 squared. So that's our new equation. Find the image of a point 3, 1 after a reflection in line with the equation y equals to x. Now, easier way to remember this matrix is it's going to swap the positions of x and y. So instead of 1, 0, 0, 1, we're going to have 0, 1, 1, 0. Alright, then we just sub the points in. 3, 1. And so our new points are going to be 1, 3. And just remember, when it's reflected on the line y equals to x, it just swaps out x's and y's. So that should make sense. Okay, dilations, so just keep in mind, try and always convert the language to parallel to the axis. If it's from the y-axis, then change it to parallel to the x-axis. That way we know which one we need to multiply. Same thing for from the x-axis, change it to parallel to the y-axis. Okay, so find the coordinates of an image of a point 3, negative 1 on the dilation of factor 2 from the x-axis. So remember, if it's from the x-axis, change it to parallel to the y-axis. So what that means is our matrix is going to be based on multiplying the y. So then it'll be 1, 0, 0, and then that number being the change. Okay, so we're 1, 0, 0, and our factor is 2, so we replace it with the 2. Then our x is 3, y is negative 1. Simply multiply it out, then we have 3, negative 2. If you have multiple dilations, you just simply multiply both of them. So just multiply both the spots. There's different k's there, so k1 and k2 are meant to represent different k's. Okay. Joe has fenced a rectangular vegetable patch with fence posts at 0, 0, 3, 0, 3, 4, and 0, 4. So A, she wants to increase the size of a vegetable patch by a dilation factor of 3 in the x direction and a dilation factor of 1.5 in the y direction. Where should Joe relocate the fence posts? Best way to do this without having to do much is draw it out. So you have 0, 0, 3, 0, 3, 4, and 0, 4. So she wants to increase the dilation by a factor of 3 in the x direction. So we have to times that direction by 3, and then that direction by 1.5. So if you look at it, the height is 4. So 4 times 1.5 gives us a 6, and then the length, the width is 3, so 3 times 3 gives us a 9. So that means we can leave A as 0, 0. B, we're going to change it to 9, 0. C, we're going to change it to 9, 6. And then D, we're going to change it to 0, 6. Joe has noticed that the vegetable patch in part A is too long and can only increase the vegetable patch by a dilation of factor of 2 in both the x and y directions. So, this time around we want to multiply it by, that's not proportional, it's more like that, by 2, so 3 times 2 gives us a 6. And then 4 times 2 gives us an 8. So our new points are going to be 0, 0, 6, 0, 6, 8, and then 0, 8. Will this give her more area? So let's have a think about area. 6 times 9 gives us 54. 6 times 8 gives us 48. So no. Alright, so in summary we have all the different matrices here. Please write it down. Hopefully you won't need the translation one, but translation, all you really need to do is just add A and B. Alright, if you're combining matrices, all you have to do is use the matrices on the previous slide and times them in order. Now the order always goes backwards, so just keep that in mind. I'll show you what I mean. Determine a single transformation matrix that describes a reflection in the x-axis. So now the first one is a reflection in the x, so that means our y values are going to become negative, so 1, 0, 0, negative 1. Followed by a dilation of factor 3 from the y-axis, which is parallel to the x-axis. So we want 3, 0, 0, 1. So to find the matrix in the middle, you just simply multiply them. You should get 3, 0, 0, 0, negative 1. So matrix is then 3, 0, 0, negative 1.